what. It's the same here. So when you see a shake of the epilepsy, the shake of the body is when this is switched off, the information is coming up. And it opens and shuts till all the 12 megabytes of coming and going is used. So what you see as a shake of the body is a switching of this point. So if you understand this, you have number of options as a doctor to handle this. And medicine doesn't work. Because if you take medicine, you have to get it all the time, or you create a plasmatic condition that the body never allows itself to create 12 megabytes. You increase the capacity through the plasmatic condition, or you settle the soul. And once you settle the soul or you change the capacity, they never have an epileptic attack. Then, from what you tell me, changing carbon, this thing is through the conductivity of the body, which is connected to CO2 or to the carbon. We do this in all the certified gas water systems we use. When you buy a system from Austria, CO2, which is certified gas medically as a medical equipment, that's what we do. So if you interfere with the electric wire and you cut it, you have a problem. Where do you cut? Or where do you create damage? Doctors don't understand. Nowadays they see the shake of the epilepsy and they try to control it. If you understand the cause of epilepsy the way we do, you're done. And it's a criminal offense in Belgium to help anybody who has had an epileptic attack and has none. Only in Belgium. The rest of the world, they greet you. You save a life. And the one who says, I'm okay, you go to prison. If you say it's damaged you. It's damaged you, I don't take 20 tablets a day. They threaten to put them in prison. And people lie not to go to prison. So now you understand the epilepsy. And if you interfere with what do you call it, with anybody who uses this, I advise you understand what you do, because the current flow goes through carbon. We know this because we use it. And then secondly, we know this takes a lot of energy. This releases because it puts a lot of pressure on the muscles. And if it's connected at a certain length, it creates, like you put your finger in your mouth, it creates convulsion. And that's why some of people who have epileptic go through convulsion, because it's like me shaking you and turning you. The stomach can't take. And then some of them which create a lot of what do you call it, foam in their mouth. We understand why. And when you look at the whole parameter of epilepsy, you know where the damage is, which part of the brain you have to handle. It's a processing, and our doctors around the world who use the technology know exactly how to use it. But when you say the carbon diet, I know where the problem is, but that is for people who got to be wise. Epilepsy, the is after
Sorry.
that. When you see the shake of the body in epilepsy, is when the accident is finished. It's a crushed body. It's not the cause of the accident. The brakes are gone. You say, what's wrong with the car? Carry on, please.
Okay, thank you, Mr. Kesh. We had a question from the Facebook, I believe it is. And it's about death. It's about, what about those who died? This question is from Hassan. What about those who have died Why don't we see our parents who have passed away coming back? Is it because of the pain of physicality they prefer to stay in the dimension they are? Are they happier in those dimensions and choose to just communicate with us in dream? Are they waiting for us to be ready to see them, or are they waiting for us to go and meet them? Thank you, Hassan.
I think you answered yourself, but you don't know what you've written. Can you read it again? And when I tell you stop, stop.
Okay. Starts out, what about those who died? Why don't we see our parents, which have passed away, coming back?
Do you
Is it
expect it
because,
physically, you mean? Carry on.
is it because of the pain of physicality they prefer to stay in the dimension they are? Are they happier in those dimensions and choose to just communicate with us in dream?
That's the word, isn't it? Listen to the teaching of last week, or the week before, or the week before that, and I explained what a dream is. You call it a dream, but this is the reality of the dimension of the soul that is leaves some impression behind because it's connected to both physical dimension and the soul dimension. That's where the CH14 and CH12 come in, and is an imprint. We're always in touch with our parents. Doesn't matter, even if they're alive sitting next to us, we still talk through the soul. But we're too physical. we we are never detached from those who come to our life, create a magnetic field with us, be it our wife, be it our lovers, be it our neighbor, be it somebody in the bus. Why do we dream about somebody we saw in the bus? We never had any contact, but you create a contact with the soul. And as I said in some of the teaching years ago, now we open the door to mankind to go to space, and you only see the space, the soul of the creatures, sometimes physicality. Then what nightmares you're gonna have? But it was not a nightmare. It's a guy you already seen, but you're not aware of it. It was sitting next to you as a dimension of physicality of is it. You call it a dream, but that's the reality of existence of your soul. The thing is, uh, us human have a very bad habit, and maybe I can explain the dream to you this way. We live, let's say, in England, and we decide to go and live in Australia. We say goodbye to mom and dad. I am gone, no contact, nothing. And then you go to Australia, and you can't go and see every day, too busy with life. Maybe a year, 2 years later, you get a flight and you go back and see mom. Was mom dead? Didn't have a life? Or just because you come back, you create you that a life for you? The soul of the man lives the same way. The soul of the mother and the father are there. They have their own dimension of living in England, and you have your own dimensions. Sometimes you meet just because you are used to dimension of physicality, and you go there for fish and chips and a pint of beer with dad. Doesn't mean they were not there. They were dead. No, you chose, and this is what it is. We just change clothes. That is not. Man has made it such a big thing, but it's just it's a change of, as I explained earlier in the teaching. We decide like that bird how it looks and what it is. They're not, as I said yesterday, they're not Gucci's and no if Saint Laurent to buy clothing in the space or for your soul. It's absolutely naked. But how do you know it's the mother you have you're talking to? Don't you have a dream when your mom is in England and you're in Australia? Was she dead, or does she come to see you? It's us, we restrict our own intelligence. But if you understand the totality, it's not there.
I think my mother talks to me more now than when she was alive.
You gotta find her husband there, I think. Your dad is not keeping her busy enough.
Well, I do get messages from my mother occasionally. She had wise words of wisdom and a certain way about her, and I just get like a flash or an imprint or impression of her presence, you might say, and sort of almost like a guiding force from time to time. But fortunately for me, it's not an everyday occurrence. I don't need that at my age.
You never know. The reality is that we got to understand what we call the dream now that we have developed the science of man, and that is part of our life. We try, or part of our brain decides to remember it or not. Why do we dream in the daytime? It's the same because the soul is in touch, not the physicality. Um, I remember talking about your mom. I remember I was in Seoul, in South Korea, and our team with the group we went for lunch. If you've been to Seoul, the Park Hotel is part of the Seoul Olympic Stadium. We were kept there for some days, uh, and we were walking down. There's like a park down the hill, and we had lunch. Coming back up, there were birds singing and singing and singing next to me in the strength of the park. And I turned around and I said to them, I know my mother is dead. You don't need to bring me the message. I know her soul is gone. I walked into the hotel and I received a call. Your mom has passed away. It could be anything, but you understand the emotion. And sometimes it's like what you say, the soul, the way how you are connected. We do not need the physicality to reach others. It's just as I said to Caroline, we come to this planet because physical life is nice. You have a lot of other bits with it. We come to experience it. Any other question, or shall we call the days nearly 3
I know we're
hours?
getting on here. Just want to show you a picture that's one of our memories from the past, and I think it's a good one to show of the previous time and reactors you were talking about earlier. It's of one of our favorite knowledge seekers, Armin, and he's dressed for the occasion in his lab coat in the lab in Italy. And he's showing that nano coating that you were talking about earlier, I believe, the copper nano coating inside.
This stops the interaction with the plastic. The one on the left, the blue one, is a cap of made in Belgium, and is a cap of I can never say the word. What do you call it? How do you clean water? Reverse uh,
Reverse osmosis.
osmosis. Yeah, that's the cap of system which was built for reverse osmosis. Yeah.
A reverse osmosis filter, I think it would be. Yeah, okay. Well, thanks for
That's how
that
he,
hint. Thanks for that hint 6 years later. We could have used that back then. No, that's great.
uh, and then you see the plastic ring was to hold it down. We couldn't frame it down. And this is this chap. He's a problem everywhere. Armin. But it's using it. It's there. Um, what other ones you have? You see on top of that blue one, you see gas control system. And the bottom of it is a motor, and you have a water cooling system in it. When I opened my lab, these guys literally ransacked with everything. Everybody took one reactor to play with. Carry on, what's the next one?
Actually, you gave it to us.
I know when Marco asked for it, I don't have one, I couldn't say no, could you? Next one. What else do you have, or is it the only one?
I just hang on a second here. We'll come up with a few.
This is our
here's one.
In northern Italy. See those
Actually,
tables?
Let me see. I think this one is the same. Let me. Sorry, you want to go ahead with something there?
A lot of memories came back.
Yeah, I know, Avancha. Behind that wall, behind that window, there's our chickens.
Oops.
Yeah.
Oh,
But you remember, you could hear them. This is again the Iranian reactor. It's used for a different space condition. When we escaped not to be killed by the Belgians, what we did, we loved our chickens, so we put the chickens in the back of the car with us, and we took them with us. And they were there. They were behind that wall. You see in the background, there is another. This is a reactor built, original reactor. It's one of the very original reactors. It took us just about 18 months to build this one. It has a specific use. It's half a sphere. It's got a twin Rutherford sphere. These rings, the copper rings, are for access for different sensors. Let me just show you what it is. This ring, for example, goes to a sensor here. This ring goes to a sensor here. So we could feel the electric currents in different position in the reactor, how it behaves, because we couldn't go inside it. This took us 6 months to find the materials, a specific stainless steel, non-magnetic. And it took about a year to shape it and then build it. We still got 2 or 3 not finished yet.
Mr. Kesh, there's another example of that. Let me show that one. Very similar, but a full reactor rather than the half reactor.
Yeah. This is his brother. You always need a two to create conditions. These are single core. This system flies. It flies in a specific condition. And when I used to run this one in Belgium, when I used to run this one properly in Belgium, when you see the window in the background, it used to create so much light that in the village we were, they could see a specific light. Space light, plasma light is different than the normal light. So poor Caroline, she literally put foams with black bags and everything, and we sealed all it, that nobody could make a complaint that there was special lights coming from this building. Because it's in the lab, And this creates a huge lights. You can walk in it, and it gives you a beautiful sensation. It's a gas field again. You can see the arrow inside it. This brings so much memories back.
We have one more system that's very similar. Let me share that one.
You see, this sits on a very powerful bearings here, because it's very heavy, weighs about 6 kilo. And you see
oops.
the brackets here suspended. It's the same one. This is the same reactor. But here...
There's a different top on it, or a different,
no,
slightly
because
different arrangement, I guess.
here it's a single feeder. But now we wanted to change gases, so we bring it to this one here. If you look at it, is like this. It's got different connections with a valve, so we could change to different gases, and this gas is connected to the tank outside the building. So we change the helium to, what do you call it, nitrogen or whatever, through it. There's a panel. This is I think a 4-section gases.
I see.
And then if you look at here, you see the contacts. Then we could, here on the back of this panel, we didn't need to go, we just could measure the electric current very low.
So you have little carbon brushes on the copper brass rings.
Carbon brushes burnt out very fast and wouldn't work in plasma. This, if you look at it, is literally copper wires.
Oh.
Wire brush. We open the multi-strand copper and you put it there to make sure it stays to each ring. This is very important. This reactor was very important for us to understand the structure of the center core of the planet, because they said it was made of steel or iron, and so we had to understand the proposition of this. Has got a rod which goes halfway to here, to the center, and the sensors come from different points, and we could see the flux flow. You could measure, you could see sometimes this one is going positive and this one is giving a negative, so we knew in there is a multi-cores. One core was getting pushed according to the speed we put in there. You have 4 sensors or 3 sensors. Each sensor, you see the minus or positive, then you knew one of the 3 cores is going opposite to the other 2. So you have a multi-inner core plasma. Now you do it with the GANs with different mixtures.
Okay, one more picture. Oh, sorry, go ahead.
This reactor is thanks to one of the directors of Keshe Foundation. Nobody knows him. He appears, he's never appeared in public, very few times. He's a gorgeous friend of ours. One of the most beautiful souls in Belgium. He put a lot of time with me to make this. And he's a beautiful man. And he spent a lot of time to help to make this built. It's an honor to know this gentleman. Next one, please. What's the next one you have?
We've got one here that you will recognize, I'm sure. It's multi-cores, lots of reactors.
Ah, yes. This is set up. You see, these are all fed through cables to each control panel. Each one of the students was responsible for one reactor. This is here, if you look in the background, that's the twin sister of this one. This is the Iranian system. This one is a twin sister of this one. This one is a twin sister of this one. This one is the one which was shown in the peace conference. It's a power generator. And this one is the ceramic one. This one was made by the guy who poisoned to kill John, the Belgian assassin. And you can see here, all of them are linked, and you see these vacuum pumps that we could create vacuum. Each student had his own table. These are all the stainless steel from the Iranian government built for us. They're specific, they're non-magnetic, so they don't interfere. And so each student had a panel with a control. They could check, they could go, we could change everything remote. Ahmed, this brings a lot of memories, huh?
Yes.
How much?
You remember the big box we built it?
Yeah, then we put this into a box with magnetic sheets that it could only keep to its side, not outside. You could filter it. We built this one as an intermediary, and then here there is a star formation, the first copper star formation Arma made, and we put detectors in both directions. This is where 129 was set up. This was very strong as a GANS. This was intermediary in returning. This was a very weak system. We deliberately made it weak, and this was a strong gas system. In trying to feed it, we built up to 129 Tesla. The machines, the detectors are sitting somewhere in the back. Uh, this unit on its own. Um,
I have some pictures too, if you like. I can send it to Rick.
it's memory time, huh? I'm trying to get this off. How did this come in? Okay. This system on its own costs around 70,000 euro to build, from design, testing, and handing over. These two are gifts of the Iranian government. When I left Iran, President Ahmadinejad ordered that let him take everything with him. He's shared everything with us. And no nation will do this. I came out, we tested, you see, in Belgium, we achieved a flight system and minus weight. It's a video in part of the demonstration, you see. These are all cooling systems. In the background, you see them to keep the motors cool. That's a cooling system for this one. This is a cooling system for that one. If you look, it's a star formation. Everything is set on the star formation set. And if you look, even the height is considered in a star formation. This one is slightly higher or lower. What do you have to share, Arman?
Here, 1 minute. How I can show you?
Here, something very you see here, you will you don't consider it. If you look here, there is a radio. We could interfere with the radio, the noise of it. It goes faint or increases. This is how the Iranian captured the American drones. We can interfere with line of communication through plasma. These are little indicators. This we knew very, very earlier on in Tehran how we can interfere block. Because this radio literally goes silent when you run it, because the magnetic field that becomes part of it does not receive any information. This frame here is where later on became the hanging basket for Arman, for his first, what do you call it, the copper rings. Arman, this brings back so much memories, huh? They're still there. None of it has been touched. They're still in Italy.
If you want, I can show.
You
Can I
want to share?
share?
Yeah, I think you should be able to go ahead there, Armin.
No, I can't.
Okay, I'm going to stop my sharing and see if we can get you set up here. Can you share there now?
We see your screen, your full picture page.
Oh, I want to show you one thing that when we done the.
We're seeing all your pictures, so maybe you want to.
This is all pictures which concern this one. If you remember this one, Mr. Cash.
Oh my God! You still got these?
Yeah, this is the one that we put it in.
First scans.
Yeah, first scans. No, you remember this one we put for 129 Tesla.
Yeah, my God. This is the walking through. You see, this is a 120 Tesla, the mother. Go back, there it is. This is the 121 Tesla.
We see the date, October 22nd, 2014.
Yeah.
This was the.
This, no, if you look
here, this one we put with the reactor we're missing.
This is the box where is the lower reactor, and this is the center system. So the fields builds up like this and come back. This is weaker. They support to do so. They keep on pulling, and you just. Americans spend over tens of millions to make 105. Look, such a small system. You see, there's a small system here on the floor. Yeah,
this one. This one, we brought this one. Then it was complete. It was 4 reactors each formation. Huh?
This reactor, yeah. The height, everything is considered to be. The reason you see they are sitting on a what do you call it, pallets, is because we separated it from the field of the Earth. If you look at the Chinese space reactors, we have made the same platform but with the cores to separate the Earth from this interaction with the system. If you put it on the ground, you have to get a lot of interference, but when you take it off the ground, it's very easy. Again, you see the Iranian space reactor. The other one, Iranian space reactor, is inside this one. Next one.
This was the other side. Can you clean it up, please?
Oh my God. I'm asking you, it is cleaned up. Here, this is the first copper dynamics flight system. Star formation. This is the reactor. When we tested in Christmas, if you remember, we called this reactor number 2. And between Germany, Canada, and Italy, we decided to stop this reactor twice by line of thoughts. So we can control. This was the first test for flights control. Oh, it's amazing how much has been done. This is the cage you see. Go back, Harmajan.
Go back 1 minute. Which one?
There was a cage. You could see the black cage completely.
Yeah.
There it is, this one. Yeah. You see the cache in full. And you see the three system lining. This board used to rotate. It was on a free floor, so it could take gravitational magnetic field pressures. And all the sensors are put in line to detect. You see there's a sensor here, measures the flow. Any other ones?
Yes, 1 minute. Oh, this one. This was first plastic reactors.
Hmm?
This was first plastic reactors.
That's cool. A good position. Yeah, they got GaNs, copper oxide.
You remember this?
Try GaNs. Yeah, it took me months, and the guy comes and says, "Oh, I can do it very fast with a light on it." But it's this one. Oh, doesn't sound like.
You remember this?
Yeah, we used to call it, you remember? With
Yeah.
the mustache. This is again nano-coated copper disc. Inside, testing high speeds. Oh, him. There's a lot of work being done testing and accumulating. Oh, it's the time to be there, huh? I just finished this weekend.
You remember this?
Yes, this is a very important tool. This is a 1 ohm resistor. Jesus, where do you keep these pictures?
This is first what we built. GaNs in it. We're measuring it.
So yeah, the current flow through the GaNs. Oh, you have a good. It's the first core reactors with the GaNs inside.
Yeah, we opened it.
Let's hold it there, hold it there. There are friends from Iranian research. I know they're in the background. This is what I was trying to explore. Go back into it. Can we have that? The green one, this one. You're just showing. When you use GaNs in your reactors, this is what you get, the hollow cavity. And if you use the GaNs material, you get this dimension. When you look at this, it shows how the system has been pulling and pushing. The thickness of the GaNs gives you a lot of information of the pressures of the magnetic field in respect to its neighbor here and in respect to the neighbor here. When you open a core, you have to understand how you open it. Where you open it, you got to mark it, and then you see a lot of things. Carry on.
This is the first day. We were in Trani. You remember this, Marco?
Yep. The institute, the government, yeah. The opening of the institute. Oh, that's good. Thank you very much, Armanjan. It brought back a lot of beautiful memories.
Thank you, Mr. Kesh.
Thank you very much. Anything else, or shall we call it a day?
Well, we have a video, one of the original videos showing the reduction in weight if you wanted to have a look at that. But I know we're getting on, and perhaps we should wind things up here, and we could leave that for next time if you like. What do you think?
Yes, let's have a look.
Okay. On a bit of a roll here with the oldies but goldies. Golden oldies.
We're always very open in sharing knowledge.
Okay, well, this is one of the big ones that came up. So
6 years of memories now, huh? We are. Is it next week? We are going into 6 years. Yeah.
It would be 5 years plus the 1 year of the public teaching workshops that we had. So it'd be a total of 6 years coming up next week, I think. Yes.
Okay.
Okay, here we go. Whoops. I had it shared. What happened? Something happened there.
It was February 15th.
See your dashboard. See your dashboard with your screen. You better reverse.
Yeah, it's on that again. Unfortunately, let me get it together here. Try again. Okay, that should show the video there.
Yeah, this is the Iranian nuclear-based reactor. Belgium testing. You go to back to Belgium. 9.1 kilo.
The current is about the same. Today is the 20th of January 2009. We have installed the cooling system, water cooling system, and the magnetic barrier for the motor that we stop any interference with the motor from outside. If we get any energy outputs, we will know that it comes from magnetic field from the inner cores. The setup is exactly the same as before. Cooling is through a small water pump through the back of the system. It's a coil, 2-meter copper coil. The water is very much a consistent flow. We have measured the voltage and amperage of the system unloaded. System weighs, with this new configuration, 9 kilograms. So we'll start loading and see what the current has started building back up to 143, and the motor has started moving again. This we cannot explain. We've seen this criteria before again. By increasing the number 5 by 30%, fluctuates and it's increasing. It does as study as before.
This is a very, very small bottle. And doesn't matter how much voltage, current doesn't restart the motor magnetic.
Do not forget that the system always sits on the same position. It's in
See, now it starts coming down from 9
change in position
9
of it.
to
So
8.
what we think it is, we're going to test something very interesting soon, and that's a cooling water cooler that the motor is kept constantly cool.
Where we say interesting thing is when we receive flights.
Again because it's a
The
very
system just
we're going to increase the amount of the
jumps up,
number 1
and
into
because he
the
hasn't got the
system.
balance, it
You
goes
can
up.
see these are the figures, these are the papers which reports are written to. Fire has been increased to
These are
200,
gases.
now we're going to increase 1 to 200 as well. Today is the 22nd of January 2009. We have taken magnetic shielding of the motor off to see the direct effect of the plasma, and if the plasma
You got
produces
to remember,
which
I
affects
came back from
performance
Iran.
of the reactor. We'll rerun the test which was done yesterday. Voltage reading of 63 millivolts AC on the system, and we will see what it comes up to. will start loading it. This is at no load, just a vacuum condition. We're about halfway through loading of the system. What is interesting, the current has picked up to 8491, and everything is constant. It is very interesting. We're halfway loading. The time is 12:32. System is set up again. It's 23rd of January 2008. There is some interesting data appearing on the voltage and the flux of the current voltages within the system. It is very, very interesting. A pattern is setting up, and if this follows, we might see certain strange appearances very soon with the system. Today is the 16th of February 2009. We're just doing a check on the weight that it is 6.97 kilos. There we are. The weight is 7 kilograms. You see the weight? Yeah. So we come from yeah. So there is the system, lower voltage.
That's the voice of Dirk.
This is a continuation of the 6.3 volts. We increase the
That's 500 watt.
there it is, 6.5 volts. There is no attachment to anywhere as usual. Very interesting. Today is the 3rd of February 2009. We are in Bruges. We try to weigh this once more. It seems to be that we try to parallel the weight once more. We measure. Yeah, definitely the weight, the gravitational field has totally broken, without a shadow of a doubt. That is fantastic. Today is the 3rd of the 2nd, 2009. For the first time we see clean cuts, drop in weight. We'll try again. The total weight of the system is 6.9 kilograms. There is a system, 6.3 kilo. We have a clear 10% drop. Clear 10% drop. Oh, this is fantastic. When I repeat this, voltage is 28 ampere, is 1544. Interesting enough, the weight is 6.4. All we done, we changed the power input. 0.66 amp, and the weight is 6.4 kilograms. So you don't really need a high speed to attain reduction in weight or gravitational field. We try this again in a few seconds. You see now the weight stands at 6.1 kilograms. It's the same loading, just that allowing the speed to come down. It clearly shows the system is in the same position. The voltage has been brought down to 10 amps and 65. You do not need centrifuge to achieve high reduction in weight. We'll try to repeat this again to confirm. There we are, 6.1 kilograms. There is no attachment, there is nothing anywhere.
You got to remember this system. So you see 3 kilogram loss, and you can fly at any time in any weights, because you can create a condition for flight, and system you don't see anymore after 6.1 because it flies. And we achieved the same thing in Tehran Sharif University months before. It was just reconfirmation that could be repeated outside. And you see those silicon rings. There is a, then we changed this ring to a steel ring. Uh, this is the steel ring. This was shipped overnight from Japan. The Iranian government didn't shortcut any budget in achieving what has been achieved.
Note, Mr. Kesh, that it's almost exactly a 10-year anniversary, you could say, with this reactor. It was made in, what was it, end of January 2009, I think. Or, no, it's February 2009, for these tests at least.
This is the testing in Belgium when I came back from Iran. When decision was made that I leave Tehran, I was happy to literally come back with my suitcase, but the office of the president decided, you can do, we have a copy ourselves. They had everything in their hand. They said, you can take it with you and you can do more with it. They packed it, everything was packed. I brought back 100 and odd kilograms of systems, which was gifted to me by the Iranian government. You see here, we could measure the pressure, what do you call it, the current flow inside. Each one we knew what it was. We could, if you see here, these are measurement machines. We could do it. You gotta understand, a flight is not a problem. Understanding the flight, controlling it is the problem. This is why we push with different systems, different groups, trying to do different ways of controlling through thoughts. Because it's very rapid. You don't see 1 second is there, next second is in the ceiling. We in Tehran, I put this on the table and the other one, the small one here. And by changing the combination of the fuel setting or radioactive material inside, I could decide which way this will fly. And we were right. I could catch it. It was like you're playing a, what do you call it? Baseball. You know where the ball is going to go, you're going to catch. I remember one of the Iranian scientists walked in and said, Mehran, you came here to make this and now you made it, you got your toy. While we were cutting this in the factory, I said to the cutter, I said, I want this, can you cut this for me? And he said, oh, of course not, why not? This was built while I was there so I could have an electron and a, what do you call it, like a proton. And it was a lot of joy making this. This steel ring is a very special steel ring. We came as a rough, and I asked the technician to cut it. He melted 2 of his diamond tips. He said, Kesh, this doesn't cut. This is a special steel. I said, you don't know how to cut. I was the only man with a suit and tie in Tehran, walking around with our people. And even in the factory, I was with a suit and tie. And I looked at him, I said, you should be able to cut this. You don't know how to use the machine. Uh, and he said, they were the top Iranian technicians, but this is a special steel I knew from my work back in England. I said, can I cut? He said, you don't know how to cut. I said, I know how to cut this steel because I know why I asked for it. And I stood on the lead machine and I cut it like a butter. He said, you're not just a tie in a suit, are you? I said, no, I'm an engineer. I've been trained to work on every machine. And it was done. I just showed him how to do it. Within minutes, they opened it, they drilled it. This is the beauty of when you know what you're looking. That's why it's easy for me to build reactors. They used to call me Achar Faransé in Tehran. It means, you know, the French have this spanner which you just adjusted with a ball, with a little ring to adjust it, the opening, different sizes. We call it, it comes from France. And they used to call me, you fit in everything, you can do everything with you. work. I've got 3 diplomas in engineering working on machinery. For me, it's easy to handle things. That brought back a lot of memories. This is after this, which the book 1 was to start being written. We stopped testing. You heard Dirk there, he said they wanted the knowledge. He said, now write what you know as a book. And I was too enthusiastic. After you heard that voice, on the way back, he said, why don't you write a book? I said, I'll write it in a few days. He said 6 months. And he was correct, it took 6 months to finish. Because they wanted to know how it's done. And I was told you only sell 4 or 5 pieces. It's a beautiful machine. It has a lot of knowledge with it. It has a lot of effects with it. You can control it to fly in any direction. I've done that with it. And it has beautiful characteristics, this system, that it feels you. Um, because it's mainly made of polymers, or even the one inside is the same. It has a type of neural connection. It feels you, you can communicate with it. It's like there is no barrier. When you work with a metal course, it's different. When you work with a blind course, it's different. Your intention, your emotion has a very linked connection with it. Um, it's an amazing system. This would have taken me a year, 2 years to build. The greening built it in 7 days. It was on my desk the following Tuesday. Tested that everything is balanced perfect.
Mr. Keshe, would you consider going back to systems like this to actually, supervise or build systems like this again?
No, really, the systems now with the gas, first of all, this is heavily nuclear um, source, heavily. And um, I have a body which can take radiation. Somehow I'm built that way. I can work with it. Um, the um, the plasma condition with the GANs is non-radioactive, so you can work with it. It's magnetic fields, and public can work with it. These radioactive materials, especially this carries, I think, in some cases we go up to 450 sources, some tests. And you have to place them one by one, attach them to the wall. Inside this reactor, initially there is a glue called helium glue, which they use for helium balloons. We painted with that we get a seal from the CO2 or from the polymers, that they don't leak inside. We create a barrier. There's a lot of little things into this structure. These are very, very difficult. Opening them and closing them used to take half a day. And you can see those silicons, you go, oh, white, you gotta clean it. We found wet tissues which was especially developed in Germany. We used to buy them in boxes to clean hand with it. It's not easy to run. But it's beautiful. You can dictate statically what can be done, what cannot be done. A lot of learning has gone into this. We learned the behavior of the plasma, how we can dent it. This produces plasmas in a much higher speed than CERN. and you can strain it. From that window, you can drain the plasma out. And when it comes out, it's very much, sometimes it's a bluish color. And the worst thing is you keep on looking inside because you receive all the fields. This window is especially made by Germans. It's a plastic window, very simple, but specifically was good for our work. And it's a shape like this. It's got a hexagonal shape on the top, and it goes down, threading inside the thing. This is like a screw, but it's specifically made for nuclear testing. It doesn't affect it. When the Belgians came into our lab, they said you're using radioactive materials. You need to um, use special detectors. And it's strange enough, only comes from Americans and American intelligence services and whatever controls the nuclear industry. They have to authorize it that they can use it. And strange enough, within 2 or 3 weeks, the American government authorized for me to be able to use the detectors. Very shocking, I thought, because they were learning with it with us. I still have it. I can't remember. They charged me thousands for it. We cannot have it. It's only used in nuclear centers. And it's a classified system, very highly classified. Um, this is used for military high-level radiation. If you're a new uranium, why do they permit you to have it? Because I used to get the information. I used to go to the American embassy to teach them, and if there was a development, I wanted help. Just ask the Marines, because the base American Marine Research Center is in UK, and sometimes they used to come out, and I used to visit. I collaborate with any nation which guarantees peace. Color, race, or religion, it does not affect the work. But as long as they use it for peace. Um, it's a beautiful system. It brought back a lot of memories. Shall I call it a day?
Certainly, it's been a bit of a longer one, and thank you for all of those little details of the previous.
Every 6 years we find something, huh? Every anniversary.
Yeah, in this case, 10 years of anniversary for when this one was born. It's almost a teenager.
Teenagers. Thank you very much. Thanks for being with us. And thank for everyone around who has been part of the work. And it's a big ladder with a lot of steps and a lot of people holding it to be there. Thank you very much. And hopefully we'll see you next week on the anniversary of going into our 7th year and see where it goes. Or 6th year.
Yeah, it depends where you start from. It's sort of an endless beginning and ending, I think, in some ways.
It's
Thank
the
you,
way it
Mr.
is.
Fish. It is, isn't it?
Thank you indeed.
Thank you, Mr. Kesh, for guiding us through all these years and giving us the bits of information and knowledge all along the way in an open manner. It's been an amazing experience and continues to be.
Thank you very much. We'll see what we learn more. I think today there is a switch in teaching that Now you understand. It's you who is responsible, and it's who's got to decide if I'm becoming man of a space or not. Nobody can say you didn't teach us. You have to teach yourself, and you have to take that step in the dimension of the universe. Thank you very much, and hopefully next week we'll learn something more.
Very good. Thank you, Mr. Kesh. This has been the 265th Knowledge Seekers Workshop for Thursday, February